Hello and welcome to Empowered Learning. This particular lesson will be on how to solve systems of linear inequalities. And so we know that whenever we're solving systems of linear inequalities, it's very similar to solving systems of linear equations. The only difference is that with inequalities, we have a range or area of solutions, whereas with a system of linear equations, we either have one solution, infinitely many solutions, or no solution. And so to remind you, we have exactly one solution whenever the two lines intersect at exactly one point. We have infinitely many solutions when the lines that are presented to us, even though they look different, are actually the same line when graphed. And then the last will be when the lines are parallel. When the lines are parallel, the lines cannot cross, so therefore there is no solution or no intersection in between them. Okay? So the steps that we're going to do to be able to graph a solution of inequalities are below, and it is a 5-step process. And so we're just going to go through it and then show that particular step process through examples. So our first step here is to draw the associated line. So I have an example here. If 2x minus y is greater than -3, then we draw the associated line 2x minus y equals -3. And so if you've checked out my other videos for how to graph lines by plotting or solving systems of linear equations by graphing, you've seen two different methods on how to graph that line. Now, the other part for step one is that if we have a greater than sign or a less than sign, then we need to draw a dotted line when drawing our line. And if we have greater than or equal to or less than or equal to, we need to draw a solid line. The dotted line basically means that we cannot include or consider points that are actually on the line as part of the solution. Whereas the solid line will tell us that we can include those numbers that are actually on the line as part of the solution. So after we do that, our second step is to choose a test point. And so normally, if our line does not go through the origin, that is to say the point 0, 0, then we want to choose that point because it makes it easy for us to evaluate what's going on. However, if our line does go through the point 0, 0, then we'll have to find some other point. And it really doesn't matter what point it is, just find one. Okay. Now, after we find our point and plug in the corresponding x and y values from that point into our inequality statement, then we find out in step 3 here if plugging in those x and y values give us a true statement, then we're going to shade the area that's on the same side as that point, in relationship to the line we just got through drawing. If we do the same thing there, which is plug in the x and y coordinates into the inequality statement, and we find out we have a false statement, then what we end up doing is shading the area of points that is opposite of where the point is. So now if we move on down to step 4, we'll see that if there's more than one inequality in the system, then after we've shaded all those areas, we want the area to where those two areas that have been shaded intersect. And then after that, we identify the correct shaded area as being our solution. So let's go ahead and put these steps into practice by doing the first example. So we have the inequality 2x minus y is greater than or equal to 5. So the first thing that we see here is that we have an associated line of 2x minus y equals 5. Okay? And of course, from here, we could graph the associated line with this. The approach that I'm going to take here is I'm going to find 2 points, and I'm going to do that by basically first finding what my slope is and what my y-intercept is. And my y-intercept will be a point, and I'll use the slope to find the other point. So here my slope is minus a over b, where 2 is my value for A, -1 is my value for B, and 5 is my value for C. So if we do minus A, which is 2, divided by -1, our answer is a 2. Okay. Now for our y-intercept, we know that that's going to be C divided by B. And so C divided by B, if we do that, it is 5 divided by -1, which gives us a -5. All right, so now we're armed with what we need to draw this particular line. So we know our slope is 2, so we're going to have a line that has a positive slope, so it's going to look something like this. And our y-intercept is at the point 0, -5. So we'll find that 1, 2, 3, 4, 5 down. And so since we have a greater than or equal to sign, according to step 1b, we need to draw a solid line when doing this. So here what I'm going to do is find some other points now and then draw a solid line. So at 0, -5, we use our slope here. This says that I can go down 1 unit and to the left 1 unit to find other points, or we could take this and translate it equivalently as saying we can go up 2 units and to the right 1 unit to find another point. So we'll do both. So for here, we'll go up 2 and over to the right 1. So up 2 to the right 1, have a point. Up 2 to the right 1. 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 So we have a general idea of what's going on here. We'll do a few the other way. Go down 2 and to the left 1. Down 2 and to the left 1. So this is what our general line will look like. And since we know that this is greater than or equal to here, we're going to draw a solid line. So I want to go ahead and do that now. Okay, so now once that's done, we can go ahead and move on to the next steps. So now that we know what's going on here with the line, we can now pick a test point. So I'm going to come here and put this in yellow. I'm going to pick the test point 0, 0. Okay. I think I'll make that another color. So let's make that green. Yeah, so our test point is going to be 0, 0, and what we want to do now is plug in 0, 0 into our particular inequality. So if we do that, then it'll look as follows. So now we'll come here and say 2 times, and of course, since our point here is 0, 0, the x-coordinate is 0, minus y, that's also 0, which would be greater than or equal to 5. Okay, and of course, again, our test point is the point 0, 0, which is in green right here. If we evaluate this, we see that we have 0 is greater than or equal to 5. And we all know that this particular statement is false. So what this is telling us is that this whole area that is on the side where the test point is not the area that we need to shade. So we need everything that is in this other area here. So if we were shading, we would shade this, and the solution to this inequality would be all the points that are either on this line here or to the right of this line in this area. So now let's move on to the second example. For this example, we see that we have y is less than 3. And so the associated line with this would be y equals 3. And we know this to be a horizontal line, or a line that has a slope of 0. So here, if we look here, we can find a few points. Doesn't matter what x is, y is always 3. So we go up 1, 2, 3. So we got 0, 3, 2, 3, 4, 3, negative 2, 3, negative 4, 3. And so here, since we have a less than sign, then we need to keep our line dotted here. So I'm just going to draw some more points throughout to represent it being dotted. And what this means to us is that we cannot consider the actual points that are on this line as being solutions to this particular inequality. So now, just like how we did before, we're going to choose a test point, and we'll choose 0, 0 again, and then we'll go ahead and just plug it in. So there's really nothing else to plug in for x, but we can plug in 0 for y, and we have that is less than 3, and of course that is a true statement, so that means we would shade all the area that is under this circle here. So let's move on to some other examples. All right, so let's look at our next two examples. So with example number 3, we see that we have x is less than or equal to 6. And so with that, we know that our associated line with this is going to be x equals 6. And x equals 6 is a vertical line which has an infinite slope, or an undefined slope. So what this equation is telling us is that no matter what y is, x is always 6. So we're going to plot some points along the line where all the x coordinates are 6. So starting at the origin here, we go from 1, 2, 3, 4, 5, 6. So we know that the point 6, 0 is on there, 6, 2 is on there, 6, 4, 6, 6, 6, 8, as well as 6, negative 2, 6, negative 4, so on and so forth. Since our sign here is less than or equal to, we need to have a solid line here. So we're going to draw a solid line going through all of these points. And so now that we have that, what we want to do is choose a test point. So again, we have 0, 0 here, and we just need to test it. So if we test, we'll see that here we can plug in something for x. We don't have any need for y at this point, and that will be less than or equal to 6. This is a true statement, so that means that every point that is to the left of this line is what we would end up shading. So we shade this whole area here, and the solution would be every point that is on this line, including all points to the left of that line. All right, so now let's go to our last example. So for this one, we'll start off working on this first inequality here. And so we want to get the associated line for it. So the associated line is 2x minus y equals 4. And so from that, here we could do the slope and y-intercept by finding the minus a over b and c over b. But this time I'm just going to solve for y to show you that we can do it that way as well. So here, if we subtract 2x from both sides, we'll get this. And then, of course, if we divide both sides by a negative 1, we will get this. So from here, we know that our slope is positive 2, and a y-intercept is 0, negative 4. And so we're going to draw our line based upon that. So At 0, -4, -1, -2, -3, -4, we're here. And so our slope communicates that we can either go up 2 units and to the right, or we could do it this way and go down 2 units and to the left. So we're going to do both. So we go up 2 units to the right 1, up 2 units to the right 1, up 2 units to the right 1, up 2 units to the right 1. And if we go the other way, down 2 units to the left 1, down 2 units to the left 1, down 2 units to the left 1. So we have a general idea of what this graph looks like. Since our inequality sign here is greater than or equal to, we need to draw a solid line. So that's what we're going to do now. So now that we have that, we'll go ahead and work on the second line. We'll do this one in red. So for here, we have 3x plus 2y equals -6. That is the associated line with that. We'll go ahead and do like how we've been doing by using the slope is minus a over b for this one. So this will be a minus 3 divided by 2 for the slope. And then our y-intercept would be c divided by b, which would be -6 divided by 2, which will give us a -3. So here this implies that we have a point 0, -3 on the graph. And here this would imply that we could go down 3 units and to the right 2 units to find another point. Or we could go up 3 units and to the left 2 to find another point. So we'll go ahead and do that now. So at 0, -3, so this is -1, -2, -3, so this point here. We'll first go up 3 units and to the left 2. So 1, 2, 3, to the left 2. And then up 1, 2, 3, to the left 2. And then up 1, 2, 3, to the left 2. And then we'll do the same thing in the other direction. So 1, 2, 3, to the right 2. And then 1, 2, 3, to the right 2. And so you see we have this general profile for how this graph looks. And so we'll go ahead and draw in that solid line now. Okay. So from this point, what we need to do is find a test point. And so here, our test point again, since none of the lines go through the point 0, 0, we'll pick 0, 0 as our point. So we'll just say test point is the point 0, 0. And now we're going to plug in x for 0 and y for 0 into both inequalities here. So if we go ahead and start on the first one, we'll plug it in and then start on the second one, we'll see what areas we're supposed to be in. All right, so taking our first inequality, we have 2 times 0 minus 0 less than 4. So we have 0 is less than or equal to 4, and that is a true statement. So what that tells us here is that for our blue line, the side that is on the same as the test point, we need to shade all that. So we'll just do some arrows here to represent that. Okay, so now we'll go ahead and move on over to our next inequality. And we'll plug in 0 for x, 0 for y again. And when we do that, our result is we get 0 is greater than or equal to -6. And of course, once again, that is a true statement as well. So what that means is, according to what we see here, we need to shade the side that is on the same side as the test point. So we'll draw some arrows here to indicate that. Okay. So now lastly, to figure out what our actual solution set is, we need the set where the two areas that we've shaded intersect. And so if we draw that out, we see that it's this area within here. So if we take this and draw it out, and then do the same thing with the blue, we'll see that it is really this section here. And all the points that lie within all this area here, including the points on the line in this particular area, would be the solution set for this particular system of inequalities. So this concludes the lesson on solving systems of linear inequalities.